My name is Mark Head. This is my colleague Deirdre. We are from a company called Ad Hoc. We build modern user-centered digital services for federal agencies and state governments. And as part of that work, we have come to find, this will surprise you, that converting complex rules in public policies into code is hard. It's costly, it's error-prone, mistakes happen. And one of the primary reasons for that is because the two groups of people who are involved in implementing digital systems are experts in different things. The policy subject matter experts, or SMEs, are experts in the policy and the context around that policy. We've seen a lot of legal documents up on this screen today, right? There's a lot of context around these policies. And software engineers, people that understand technology and how to write code and how to set up cloud infrastructure. So we took a little bit of a different approach than some of the teams. Our goal was not to apply large language models toward the sharp end of the stick where the benefits are being administered or questions are being asked, but more earlier in the cycle, so to speak. We wanted to find a way to use large language models to make policy SMEs, policy subject matter experts, the people that are better able to determine whether or not a system has been implemented correctly. So the approach that we came to as we started to work on this was using LLMs in a workflow where a policy is described in a domain-specific language program. This program has features that will help ensure accuracy and completeness, and our goal was to position SMEs, policy SMEs, as the correct arbiters of whether or not a system has been implemented properly. Empowering SMEs, that's what we're about. Like a lot of the other teams, we used Claude 3.5, and we also used the Medicare prescription payment program policy from CMS. That was the right one, right? Okay, just making sure. We wanted to determine a few things. One, like many other teams, we wanted to determine how well a current generation LLM could produce valid DSL code directly from a policy document. Because we didn't have access to policy SMEs at federal agencies, we wanted to use other folks that we had more access to help us verify what we were targeting. Our ultimate goal is to show those folks, to show policy SMEs in government the value of this approach and that they can use these tools, not unlike software developers and other people are starting to use LLMs. There was all this discussion when LLMs hit the scene that they were going to displace white-collar workers, they were going to replace software developers, and now we're finding out through a lot of current research that's not true. Software developers and other people are using LLMs as productivity tools. When they're used properly, they can help software developers and others do their jobs better, and we believe that policy SMEs are in a similar situation. Deirdre?
All right. So you heard Mark mention DSLs. Oh, I thought this guy was picking it up.
I don't think this one works. I think it's either that.
Oh, okay.
All right. It's on. Go ahead.
Should be on.
Yeah.
On? Yeah. Okay. So you heard Mark mention DSLs, domain-specific languages. So the approach that we were really focusing on was, could we come up with a DSL that would be useful to policy subject matter experts, and could we get an LLM to actually generate valid code in a language that it hadn't seen before? So in order to do that, there were a few things that we needed to be sure that LLMs could do. They had to be able to generate code in a known language from policy. They had to be conformant to the grammar. It had to be able to fix mistakes that you pointed out to it, and it needed to be able to document its output, because you've seen in some of the other examples, being able to cite the particular regulation that you're implementing is really important to subject matter experts. Next, where's the click? Okay, so what we're showing you here is we're looking at our first experiment that we did to try and prove this point that, yes, Claude could actually take a policy document, it could turn it into valid code, and we could turn it into valid code. The valid code is there on the left, your right. It's generating Go code here. The Go code was syntactically correct. It compiled and it produced a valid result. So that was a yes. so that was one of our first experiments, and then it was, I'm sorry?
Go to the next one.
Yeah. So once we proved that point, we moved on to the next one. We said, okay, can we actually get the LLM to understand our DSL? So in this experiment, we fed it the grammar, we fed it an input document, we fed it a somewhat detailed prompt that you can see up there, and then we generated the code. And here what it's done is it's produced code that's valid in our DSL. It is syntactically correct. It's using keywords in the language that we know are in the language and are not in general languages, so we know it's using the grammar. And what it has done is it has taken the policy, it's summarized all of the data structures in it, it's summarized the rules, and it's summarized the relationships, the rules that establish relationships between the different data types that are in the policy, that are in the DSL program that it generated. So, next slide. So what we found, we can actually use a defined grammar. The LLM can actually, this particular LLM, Claude, was able to interpret grammars, it was able to write grammars, it was able to edit grammars. So that really surprised me. I really did not expect that, but that was an important part of the investigation that we did, because if it didn't have a concept of how computer language grammars work, it wasn't going to be able to do the kind of interpretation that we needed it to do. So that was a really key finding. Another key finding is that, that it was really sensitive to the input grammar and the amount of ambiguity in the input grammar. So input grammars need to be fairly tuned to work, to work with the LLM that they are.
Don't download that.
To work with the LLM that they're intended to work with, it seems. The other thing is, well, let's see, it's not up there. You've heard this a lot. You need to validate what that LLM is doing. You can't trust it out the door. You may know that it's generating valid grammar, but you have to check to make sure that it's actually picking up all of the pieces of the policy that it actually needs to pick up, and that it hasn't missed something that you needed to. The nice thing is you can say, hey, you forgot this, would you please go add it back in? And it will do that perfectly happy, at least Claude will. One of the things that we're doing is we're looking at building validations into both the tool set and the language itself, so that you're getting it in both places. And
to me, one of the most important findings is we can use LLMs as part of the tool chain. We can enable policy SMEs to be better arbiters of correctness in a system. What are we going to do next? Well, we're going to include some actual government policy SMEs. In the next phase of work, we're going to further develop our grammar. We're going to widen our sample of policy documents. We want to see how this works with a whole range of policy documents. And we're going to continue to refine our DSL validators. So onward to more empowered SMEs. Thank you.